Hi, today's lesson's on dividing polynomials. So first thing we're going to do is we're going to use long division to divide polynomials. We do it exactly the same way as you did back in 3rd or 5th grade, whenever you learned it. So we're going to use the division box. So we're going to first write x plus 3, and then draw the division box next to it. I'm going to copy this into the division box. Now from here, we're going to go through and we're going to divide one term at a time. Everything gets divided by the first term here. So we're going to go one at a time. So x cubed, I'm going to focus here, x cubed divided by x is x squared. And then from there, we're going to take this and we're going to multiply all of this by x squared. So we get x cubed plus 3x squared. Now from here, there's a trick. We're going to subtract it, which means just change the signs and add. So these cancel, and this gives you 2x squared. Now bring down the next term, and now we do it again. So we're going to go 2x squared, we're going to divide it by x. So we get 2x. Distribute that, so we get 2x squared plus 6x. Change the signs. These happen to all cancel, so they just go away. So we just bring down the 9, which is your remainder. So from here, what we do is we add 9 and put it over x plus 3. And there's your answer. Go ahead and try this problem. All right, let's do another long division problem. This one is a little bit trickier. If you notice, this thing is missing exponents. So we need to rewrite this in order to solve it. And this one's a little trickier because it's got the 2x plus 3 there. So same story though. Draw your division box. 2x plus 3 on the outside. But when we write the inside, we got to take into account every single exponent that's missing. And let me explain what I mean by that. We have 8x cubed plus 0x squared plus 0x plus 27. And if you notice, if this has an exponent of 3, there should be 4 terms. There's always one more term than the exponent, or the degree, if you will. So same thing. Take this, divide it by 2x. So we get 4x squared. Multiply that, 8x cubed plus 12x squared. Change the signs. So this cancels. So we get negative 12x squared. Bring down the 0x. Now do it again. Negative 12x squared divided by 2x is negative 6x, which gives us negative 12x squared minus 18x. Now change the signs. Add them. 18x. Bring down the 27. Now let's do it again. 18x divided by 2x is plus 9. So we get 18x plus 27. Change the signs. And we get a remainder of 0. Since it's 0, we don't have to write anything, which more so means this is a factor of this. In other words, these two multiplied together equal that exactly. Try this problem. Now I'm going to teach you how to use this thing called synthetic division. Synthetic division really works well with these types of problems, and pretty much only these problems, without trickery. So if it's in this form where it's just a number by itself, we can use this method. So first of all, we need to make sure we're not missing any terms here, which we'll deal with in a second. Okay? Actually, let's deal with it now. So we get 2x cubed minus 7x squared. What is it missing? It's missing the x. So I got to bring that in. And the reason I bring that is I just need these numbers in front. So to do synthetic division, you do the opposite of this, which is 3. Now we copy each one of these numbers with some space. 2, -7, 0, -4. And then at the last one, put a little hook there. This is the setup for synthetic division. Bring down the 2. Now the rule is for synthetic division is multiply up, add down. So we're going to multiply up. What I mean by that is pass the line. And then add down to under the line. Cool. And our multiplier is 3. We're only going to multiply by 3 and that's it. So 3 times 2 is 6. So we multiply it up. Now we're going to add down. So -1. Now do it again. 3 times -1, -3. Add down. Same thing, multiply up. -9. Add down. -13. And now from here, since we had an x cubed and we divided by x, it's going to be x squared. So we write our final answer as 2x squared minus 1x, or just x, minus 3, minus 13 over our original. Like that. And that's how you do synthetic division. Go ahead and try this problem. Try this problem. Now, I alluded to the remainder and factor theorem a little bit, but basically, if you divide and it goes to 0, that means it's a factor. So what the remainder theorem says that whatever you divide by this form, it's the same as plugging the number into the equation. It's no different whatsoever. So let me show you what I'm talking about. It's pretty basic. So we're going to see if this is a factor, but we're going to use the remainder theorem. We're not going to use synthetic division. You could do synthetic division, but basically if you do that, you want to see if you have a remainder of 0. But it's a little bit faster if you just plug it in the calculator. So the opposite of this is 6. So we're going to just take 6 and plug it in for all the x's. So P of 6 equals 6 to the 4th minus 8, 6 to the 3rd plus 16, 6 squared minus 23 times 6 minus 6. And you just plug this in the calculator as it looks, and it happens to equal 0. Since it equals 0, is it a factor? Yes. That's simple. So same with this one. This one's going to be -3. So we're going to plug it in, P of -3. So -3 to the 5th minus 5 times -3 to the 3rd plus 9, -3 squared minus -3 plus 3. Plug that in the calculator, you get -21. So no, it is not a factor because that's a remainder. Be careful when you type this in the calculator, use parentheses and watch your negatives. The benefit to using this method instead of synthetic division is if you notice I'm missing an x to the 4th, but I don't have to worry about it if I just plug in the number instead of doing synthetic division. Go ahead and try this problem.